Well, hey there, this is Mrs. Sharp, and this is a pre-lab tutorial and instructions for the lab called Endo and Exothermic Reactions. This lab is meant to help you understand LTA 7.1 a little bit better, the tail end of it especially. So what I'm going to do here in this tutorial is kind of talk you through the lab to understand some of the concepts that you're going to see while you're performing it. So if I were you, I would have that lab handy and feel free to make notes on it or on a separate sheet of paper. Your pre-lab is actually going to be a quiz on Edmodo, and you're free to use any of that information that you write down. So here we go. This comes straight from your notes, just a reminder. The overall change in energy in a chemical reaction is symbolized by the symbol DH. And that actually is supposed to be the Greek letter D, which is delta H. So that symbol actually looks like that. Change, meaning change. So change in H is the change in energy of the reaction. So if delta H is positive, that means the overall reaction is endothermic. So again, this should be in your notes. But if you have a thermochemical equation where the delta H is any positive number, positive 428, positive 117, positive anything, then that means you have an endothermic reaction overall. On the other hand, if your delta H is negative, any number, negative 7, negative 324, it's going to be an exothermic reaction, which means it releases energy into the environment. And that is usually measured in joules or kilojoules to show how many joules or kilojoules are absorbed in the case of an endothermic reaction and how many joules are released in terms of an exothermic reaction. So please make sure that you know this for your lab. That will be very important. And again, that should be right in your notes for 7.1. But just a reminder, friendly reminder. This is also in your notes, but I just want to go over it one more time. In an exothermic reaction, let's do an example here of an exothermic reaction where you have, let's do lithium combining with water. If those are my reactants, the bonds in those reactants are going to all need to be broken. And as we learned in our last unit, anytime you break bonds, energy is required to do that. So that's always endothermic. So a reaction is always going to start off endothermic in order to break the old bonds between the elements in a compound. However, new bonds are always made in a chemical reaction as well. So when those atoms of lithium and hydrogen and oxygen, when new bonds get made, so remember we started with Li plus H2O, we would get lithium hydroxide and hydrogen gas. Making new bonds always releases energy, so that part is always exothermic. So you always have exothermic and endothermic happening at the same time. In a chemical reaction, it's always endothermic to start and then exothermic to end. And it always just depends on the magnitude of those two arrows. Now in this case, we can see that the energy released is more than the energy that was required. So this reaction overall is going to be called exothermic. So because the darker purple arrow there outweighs the more bluish purple arrow, that means your delta H is negative and it's exothermic. And delta H is negative because, as you can see, the energy from start to finish is going down. So the thermochemical equation here, which shows the delta H, might look something like this, where we would have the lithium plus the water. Those are my reactants. We might even put their state, if we were being very thorough, solid and liquid. And then we would put the products, which would be lithium hydroxide, which would actually dissolve in the water, so it would be aqueous. And then hydrogen gas, which remember we can symbolize by an up arrow. And then we'd have a little bit of space here. You don't have to actually draw those dots, but you have a little bit of space. And then you put your delta H. And since this is an exothermic reaction, this would be a negative number. And it would be some number value depending on how much of that lithium that you used. So any number that's negative would indicate an exothermic reaction. And that's called a thermochemical reaction, or an equation, thermochemical equation, sorry, when you show not only the reactants and the products, but you also show the overall change in energy, delta H. So let's talk about what this means for your lab, because your job is going to be to decide if a reaction is overall exothermic or overall endothermic. So let's talk about a couple of new terms for this lab called the system and the surroundings. Now the system is always the reaction or the process being studied. My son is singing in the background there. So if the system is the reaction or the process being studied, that's really what you're going to be studying in your lab. So in part 1, when you're looking at your citric acid and your baking soda, those two things, those reactants, would be considered the system. Now the surroundings are everything else in the universe. Okay, so that is
system.
So that could be the water that your citric acid is dissolved in. That can be the beaker or the test tube that the whole thing is in. That can be the ring stand. That's you. That's the parking lot at Western High School. It's everything. And so here's the thing. This part is the only...
Saturn.
It can be Saturn, Rosalind says. So we cannot take the temperature of the system very easily. It's hard to stick your thermometer right into the atoms that are reacting. But the thing about the system is that if it releases energy into the surroundings, that's very easy to measure the temperature of. So I'm going to draw another picture here. So what we can think of here is that we have our reaction, which is our system. And then we have the surroundings, which is everything else in the universe. So in an exothermic reaction, we're going to have energy flowing from the system out. Remember, it releases energy into the surroundings. So if it's exothermic, then what should happen to the temperature of the surroundings? Well, if the surroundings is gaining that energy, then the temperature should increase. So what you guys are going to see in your lab is that if you have an exothermic reaction that's releasing energy, the temperature readings that you get of the surroundings, which are going to basically be the water that's surrounding the reaction, because all of your reactions are going to be taking place in aqueous solution, which means all your reactions are happening in water. So your direct surroundings are going to be water, and that's what you're taking the temperature of. So if you have an exothermic reaction happening, that means the temperature of your surroundings, the water, is going to go up. So if your temperature goes up of your surroundings, then that means that your system is releasing energy. So it's exothermic. That's important to know. Okay, now in an endothermic reaction, kind of the opposite thing is happening. So remember that in an endothermic reaction, again, energy is always required to break those old bonds. Always. You always have to put energy in first. And then energy is always released to make new bonds. So we still have arrows going up and arrows going down. The first part, breaking those old bonds, is always going to require energy. And the second part is always going to release energy. But in this case, the amount that's released is not as much as what was required. So that means that this reaction is overall endothermic. Again, both are happening, but overall, delta H is positive. So look, from start to finish, the energy is going up. So what this would look like for your system and your surroundings is we would have our system in the middle, so our reaction, and our surroundings, And so if our reaction requires energy, it's going to steal it from the surroundings. So look at what happens this time. The surroundings gets its energy stolen from the system. The system needs that energy in order to happen, and so it kind of steals it from the surroundings. And so when it steals it from the surroundings, that means the temperature of your surroundings has less energy, so the temperature is going to decrease. So when you're looking at your water and your temperature goes down, that means that your reaction that's happening is endothermic. It's stealing energy from the surroundings, which is your water. So since we can only in this lab and in most things actually measure the temperature of the surroundings and not the system, we have to know what's going on in order to label the reaction, which is the system, as being endo or exothermic. So because energy is coming in, this reaction will be endothermic. Temperature of the surroundings would decrease. So this is going to be a really cool lab. The pre-lab assignment is on Edmodo. It's a quiz. There are 8 questions, which are multiple choice, and a 10-minute time limit. So you really want to make sure you're ready before you start that. And it's got to be completed before class if you would like to participate in the lab. If it's not done by the time class starts, you will be doing an alternate assignment after you complete the lab, which is a bummer. So, and I will tell you, it involves some cleaning as well, so it's not going to be nearly as fun. So get that pre-lab 8-question multiple choice done, and we will do a really cool lab very soon. So thanks, guys. Have an awesome day, and I will talk to you later.